Good evening. I thought I'd put out another pencast of graphing with exponential and logarithmic equations. There is already one out there in my materials that have been sent out previously, but just to kind of reinforce this first equation, we have y equal 3 to the x plus 1 and that quantity minus 2. That's going to indicate a basic y equal 3 to the x as our parent function. So just to kind of reinforce what 3 to the x looks like. 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. There's basically the left side, or the right side of the graph. 3 to the negative first is 1 over 3 to the positive first. So that'd be 1/3. And then we'd have 1 over 3 to the negative second would be 1 over 3 to the positive second, which would be 1/9. Okay. Ultimately, it looks like this. With a horizontal asymptote at y equals 0. So there's your basic in red. Now, in our case, we've moved left 1 and down 2. So to start this graph, I'm going to take a key point, and I'll do this one in blue. The order pair 0, 1 is going to move left 1 and down 2. So it would now be here. Okay, so that point is moved. The asymptote, which was at 0, is moving left 1 and down 2. So normal y equals 0 is going to move down to y equal -2. Okay, so basically this common point moved, and we're going to see that same basic graph moved to the left and down. Now, to help us out a little bit, I'm going to go ahead and reinforce the idea of plotting points. So I'm going to fill in 0 for x, and if I did that, I'd have y equal 3 to the 0 plus 1. That minus 2. That is 3 to the first minus 2, which is 3 minus 2, or 1. So I end up with 1. Okay? So the order pair 0, 1 is a point on this graph. So now that is our new point right there. Okay? And then I'm going to go ahead and fill in, say, 2. And that'd be y equal 3 to the 2 plus 1. And then that minus 2, so that's y equal 3 to the third minus 2. Y equal 27 minus 2, or 25. So over 0 up 20, or excuse me, over 2 up 25. So it's going to be way off the screen up here at the top. So I'm just going to kind of exaggerate that up by 10, but really that's up at 25. So it's climbed quickly. In the negative direction, if I fill in an order value like -1, just to emphasize, I would have 3 to the -1 plus 1, and then that value minus 2. That would be 3 to the 0 minus 2. And 3 to the 0 is 1, so 1 minus 2 would be -1. So my point here is at -1, -1. That's the one we just found, or the one we found earlier when we were shifting. Now, we'll go ahead and do one additional point. We'll say -2. So I would have y equal 3 to the negative first minus 2. Well, 3 to the negative first is 1 over 3 to the positive first. Minus 2 would be -1 and 2/3. So I would be the order pair -2, -1 2/3, which is right down there by the asymptote. So we can see that this graph basically is going to do this kind of thing and go up steeply like so. Okay, so it's shifted to the left and down, and otherwise it's followed basically the same path, or the same basic structure. Now, my first graph wasn't that great, so maybe it follows a little too closely. Our blue graph's pretty accurate. Okay, our next one we're going to be focusing on is, well, while we're at it, let's go ahead and throw in a couple, just some additional ideas of domain. So my domain is limits on x. And in an exponential function, I can pick any x value I want. If I look at the graph, it goes infinitely to the right and very quickly climbs, but it's still going infinitely to the left and infinitely to the right. So my domain is -infinity to infinity. Okay, my range, limits on y. I look at the graph and I can see that my y values are starting here at -2. And they're working their way up. Okay, so my range is from -2 to infinity. Okay, the next equation we're going to work with is a log equation. We seem to have a few more problems with this. Our log base 2 graph is the inverse of an exponential graph. So on the exponential graph, we had the order pair 0, 1. So on the log graph, we're going to have the order pair 1, 0. We reverse x and y. Okay. On the exponential graph, we had x equals 0 as a horizontal asymptote, or y equals 0 as a horizontal asymptote. So we're going to have x equals 0 as a vertical asymptote. Okay. And if we're thinking about y equal log base 2 of 2, that's looking at powers. Okay, so if I fill in, for example, x is 4, because I'm looking at powers at 2, it would be saying log base 2 of 4, which is 2 squared. Okay, and that exponent, 2 squared, that's saying 2 to what power is 2 squared? It's 2. So I would have the ordered pair 4, 2. Okay. Similarly, if I filled in another power 2, so I'm going to say 8, I would have log base 2 of 8, and I would get 3 because 2 cubed is 8. So up at 8, it's only up to 3. Okay, and then the next power 3, or excuse me, the next power 2 is 2 to the 4th, so at 16 it's up at 4. Next power 2 is 2 to the 5th, so at 32 it's up at 5, so it's very slow climbing. As we get closer and closer to this vertical asymptote, it looks something like that. Okay, if we continued approaching 0 from the positive side, we'd find that y is approaching -infinity. Okay, so that's our basic graph. In our case, we're looking at a graph that's moved right 1 and up 3. So I'm going to take this key point right here, and I'm going to move it from 1, 0. I'm going to move it right 1 and up 1, 2, 3. So it was at 1, 0. Now it's at 2, 3. There's the corresponding point. Okay, similarly, my vertical asymptote at x equals 0 is going to move right 1, so it's now going to be at x equal 1. So remember, this point right here is on our original graph, not on our new one. Okay. The next thing, we should basically see a graph that moves to the right, just like the old one. It's been shifted up and slightly to the right. Vertical asymptote's now at x equal 1. Now, we could go ahead and fill in, but I'm gonna start actually filling in some numbers. And when I fill in numbers, I'm gonna think I need numbers for x, so I end up with a power of 2 since it's base 2. So right here, this base tells me I want powers of 2 inside for all of that. So what I'm going to do is I'm going to fill in, to start with, 3, because just to kind of emphasize this, that would become log base 2 of 3 minus 1 plus 3. Now, the reason I do that is log base 2, that would simplify to a 2, and this quantity right here is saying 2 to what power is 2? It's 1. So that's 1 plus 3, or 4 for this value. So I have the order pair 3, 1, 2, 3, 4. Okay? Now it'd be nice to spread those points out a little bit, get further to the right. So what I'm going to try to do is pick a larger value for x that would give me a power of 2 inside. So I know, for example, 2 squared is 4. So if I put in a 5 for x, I'd get a 4 inside. Okay, that wouldn't be bad. 2 cubed is 8. So if I put a 9 inside, let's do that, I would have y equal log base 2 of 9 minus 1 plus 3. 9 minus 1 is 8, so this becomes log base 2 of 8 plus 3. Now, log base 2 of 8, this quantity right here, is saying 2 to what power is 8? Well, 2 to the third is 8. Plus that extra 3 gives me 6 for my y value. So over 9 up 1, 2, 3, 4, 5, 6. Okay? So you see in the same basic graph, it looks something like this, and as we approach the asymptote, it's going to go infinitely downward. Okay, my domain. Starts at 1 and moves to the right, so x is greater than 1, or from 1 to infinity. It can't reach the vertical asymptote. My range in this case, it goes infinitely downward, so it's going from negative infinity. And although it's very slow, if I fill in log base 2 of 1,000,000, I'll still get a y value back out. So it is slowly climbing, so it's going to go to infinity. Okay, that gives you 2 additional examples of working with graphing exponents and logs. I hope that helps a little more along with the ones we've already given before. Thank you.